Okay, so yesterday we talked about bonding. Today we're going to talk about the reactions things have when they bond or whatever they do. So first thing, we've got two types of reactions, physical and chemical. A chemical reaction happens when chemicals combine together or if they just react to each other, and they're going to make new chemicals. So something new is going to come out of a chemical reaction, okay? When these changes occur, if something new happens, then a chemical reaction took place. All right? Remember, we talked about these elements aren't just destroyed. What happens to atoms? Instead of being destroyed, what do? They just move around. They change and get rearranged. So all the atoms that you start with are still going to be there in the end. They're just going to be a different order, and they're going to look a little different, okay? So chemical bonds are broken, and new ones are formed. So something else, whatever you started with, just changes to something else, all right? So for chemical versus physical changes, a physical change happens if, be quiet, if your thing changes appearance, but it's still that same thing. So your element is not changing the element, it's just changing what it looks like. They used ice as your example here. So what makes ice? Water. So when ice melts, what does it become? Water. It's still water. It just looks like a different water. Okay? So you can have physical changes by melting something, boiling, breaking, cutting, ripping, or dissolving. But it's still going to be itself. Okay? A chemical change makes something new. It actually changes to something else. So they used fire here. If you're burning hydrogen, in order for a fire to actually burn, it has to have what? Oxygen. You can't create fire if there's no air. That hydrogen connects with the oxygen and actually creates water. Okay? So these two changed into water. So to decide if a physical change happened or a chemical change happened, you just ask, is it the same substance you started with? Yes, then it's physical. No, then it's a chemical change. Okay? Yes. We can talk about this. We're going to do more of this tomorrow. But you started with 2 H2s. So how many H's is that? It's actually 4. Because there's 2 sets of 2. And then there's how many O's over here? 2. And when you go over here, yes, this 2 now is in front of both of them. So the 2 goes to the H and to the O. So how many H's are over here? 4. This made 4 H's. How many O's are over there? They are still 2. So none of them got destroyed. But we're going to talk about that number stuff more tomorrow. Any other questions? Okay. All right, so evidence to decide what kind of change took place. If you've got bubbles, bubbles are gases forming, except in your pop. So if your soda pop is fizzing, that's actually a physical change. Right. It's carbon dioxide, but it's just moving. Like it's popping out of the, where's it going? Into the air instead of out of the, yes. So it's not changing the gas it is. That gas is just moving. Okay? But besides that, most time bubbles are evidence of a new gas forming. If your things turn cloudy, something is solidifying in there, a solid is forming. You can feel temperature changes. That means bonds are breaking or forming, depends what you've got happening, what's combining. Color changes are new substances. And then if it smells or tastes differently, that's also a new substance. We are not going to taste anything we're creating today because while your tongue and nose are really good at telling you if there's a change, a lot of these things are harmful and or fatal. So like nothing we're going to use today is going to hurt you. But at home, be careful. Don't mix ammonia and bleach because you will make chlorine and you could kill yourself.
Yeah, me too.
Well, chlorine gas is the poison part. So don't do that in your bathroom. Ammonia and bleach in your bathroom. Don't do it. Just don't do it. Because too many people make chlorine gas, which is poisonous. Okay.
Why are you not supposed to clean your cat's litter boxes with bleach?
Because their pee has ammonia in it. Yes, don't clean your litter box with bleach. Yeah. So, moral of the story, just don't do it.
Yeah, what's up with that?
With what? What'd you say? All right, let's talk about these. Is salt dissolving in water a physical or a chemical change?
Physical?
Okay, why do you know it's physical?
Because it changes the taste of the water.
Yeah, like it just dissolves. It's still salt, right?
Have you ever gargled salt water?
Yes, I have. And you can definitely tell there's still salt in there. It just dissolved, but it's still salt. You put it in your mouth, you can tell it's salt.
Taste salt water,
Yeah, you can tell.
You get a little cloudy to it.
So like that solid has just dissolved a little, but it's still there. It's still salt in the water. Okay? What about wood burning?
I think it would be both.
Okay? What happens?
Burning the wood and charring it into ash, that's a physical change, but the smoke it inside.
Okay? So when you burn the wood to ash, is it still wood? No. Okay? So if it changes the thing it is that physical or chemical? Chemical.
I have to do something. Can I talk to Mr. Stewart?
Sure. Okay? What about when you dissolve sugar in water?
Physical, same thing as the salt.
Yeah, you can still tell. Like if you get your sweet tea, you can still feel the sugar in the tea, right? Yeah. Yeah, if it's not water like hot. But even when they do put it in hot water, like you still taste the sweet sugar. Sugar is still there. Even though it's dissolved. What about water boiling? Okay? When the water evaporates, does it become something new?
Yes.
What does it become?
Steam.
Okay? What? Steam is what kind of gas? The gas form of what? Of water. So did it change?
Yeah, change.
Did the water change into something else?
changed into a gas.
It changed form, it changed its state, but it's still water vapor, right? It would be physical. Okay, so the water evaporates, but it still stays water. It just becomes water vapor. All right, and then baking soda and vinegar. Yeah, that's not just like a liquid and a solid anymore. It's a foamy something else. Combines into a new thing is what we're going to say. Okay. Do you feel comfortable deciding physical change or chemical change though? Just remember, physical stays itself, just it might change states of matter or something like that, but it's still itself. A chemical change produces something new. Turn your page over. We're also going to talk about this just with the digestion process in your body. So, multi-step process. First step when you eat something, you put it in your mouth and you chew it up. Physical change. I want you to explain your evidence just on your own. I cannot spell. Physical. So, in your own words, just write a word or two about why that's a physical change. What's happening when you chew your food. If you're watching the video and you need more time, just pause to write your stuff down. What about your saliva? So it says pre-digestion. Through enzymes in the saliva, it also softens your food for swallowing. Yeah, the enzymes in your saliva are breaking that down. So that's chemical. Okay. What about in your stomach? What's happening in there? Chemical. Because why? Okay. Make sure you're writing that down. Your body takes the food and produces heat and nutrients. What about in your intestines? It literally says there, more chemicals. It's breaking your food down into usable nutrients. All right, and then digestion, the entire process of chewing and digestion through the body. So this is going through the whole thing. Why did I write chemicals? Part of it is chemical, and part of it is physical. So the whole process is actually both physical and chemical. All right, so to get all the points on this page for participation, you do need to answer those evidence parts, but we have talked about them. All right. The last piece of this, we're going to start today, but this is what we'll be working on mostly tomorrow. So there's a code. When these reactions happen, whatever things you started with are called the reactants. So they're the part on the left. The things that are combining or breaking apart, whatever it is. Here we've got two hydrogen and 2 hydrogen 2s and 2 oxygens. We talked about this a little bit when Tyler asked the question, but these coefficients tell you the number of molecules. So like we have H2, but we've got 2 of those. No, because these are going to combine and just make water, but it's just going to make 2 molecules of water. So H4 is a completely different thing. So that's why they use the coefficients. But there are a total of 4 hydrogens here, because you basically multiply this coefficient times whatever number you've got. And then we're adding those hydrogen 2s to 2 oxygen molecules, or 2 an oxygen molecule. It's 2 atoms together already. And then this arrow tells you that your reaction is happening. So your reactants produce or yield the product, and the product is what you get after the reaction takes place. So they are what's produced. This subscript, the little number, is how many atoms, or ions depending if they're charged, are in your formula. So H2O means 2 hydrogen atoms combined with 1 oxygen atom. And they got this little one down here, BeNO3, and then the parentheses around that, and then another little 2 means that 2 is only going to the NO3. If it's in front, it goes to everything. But if it's with a parenthesis, it only goes to the part it's touching. Does that make sense? It's kind of exactly like in math. If you've got a number out front of everything, you distribute it to all the pieces. Okay? So here, there's only 1 beryllium, but there are 2 nitrogens and 6 oxygens, because that little 2 is going to just the parts in the parenthesis. So we're going to look at these reactions and just decide what the things are, how many there are. So for Li2O plus MgCl2, what is the second reactant? What side are the reactants? Which way are you talking? To the left. Okay, just say the word. Okay. So the second thing on the left side of the problem is going to be what?
The oxygen 2?
Left side of the problem.
Yes, I am on the O. The MgCl.
MgCl2 is your second reactant. So reactants are on the left. Products are on the right. So then it asks, what's our first product? 2LiCl. Okay? And then how many lithiums are on the product side?
What?
Yeah, so lithium is that Li part, but they put the 2 out front. So there's 2 lithiums. Okay? And then jump down here to this one, the Fe2O3. What's the first reactant here? Fe2O3. And then it's asking for the total atoms on the reactant side. So before we get into this, what does it mean for atom? What? Okay.
Is it going to be that number?
No, not the atomic number. So on the reactant side, what? No. So be careful. The atom part,
Is it 22?
also too high. So like, hold on. Remember this Fe2O3 is a compound, right? How many atoms are in that compound? There are two elements. There's,
Is this where we found like the spot, the missing spots?
yeah, you don't have to do that for these.
Okay.
So like, you see, you have Fe is iron, right? And O for oxygen. But how many irons are there? Two irons. Because they got the little, where did we get the two? The little subscript is telling us two Fe's, which is iron. How many oxygens? Three of those. That is, so that compound has five atoms in it.
But didn't we say 5?
But that's not all. Because this is also reacting with three, is that carbon? 3 carbons. Nope.
Oh wait, 8.
8.
Sorry.
2, 3, and 3.
Someone said you said 6.
Yes. So that's why I want to do this one. Because we've talked about compounds, molecules, and atoms, but they're asking for how many of all together, every piece, all the way broken down is one atom. So that's for the reactants. Going to do the same thing for the product. So our first one over here, excuse me, Fe stands for iron. How many irons are there? Just 2. Our next letter, the C. How many carbons are there? There are 3. So you have to pay attention to the subscript and the coefficient out front. And then we also have oxygen, but there are 3 of them. So we're breaking, when they ask for the atoms, we're breaking these compounds down into their building blocks, okay?
So these have 8.
Again, 2 plus 3 is 8. And remember, we're not destroying any of these, we're just moving them around. So these should always be the same. All right, I want you to do those other 2. Pay attention to what they're asking, because like down here it says how many sodium atoms.
What does that mean?
What does sodium mean?
Is that just one of the elements?
What? Oh, which one says give the formula? Oh. I think just the whole thing. So like what is the second reactant? Yeah, since that's like a big compound, they just want you to say all of that. Like don't leave out the coefficient or anything. The whole thing. It's the same, it's really asking the same question, but they want you to make sure you have all the numbers. Okay, so finish up those 2, and then we got our lab to do.